Bill Nye the Science Guy.
This is trigonoplanar because there are 3 bonds with 0 unbonded pairs, and it's a triangle on one plane, therefore it is trigonoplanar. The angles are 120 degrees apart from each other and is nonpolar because the charges focus onto the nucleus and they cancel out. This is bent because there are 2 bonded pairs and 1 unbonded pair, and makes a bent look. The bond angles are less than 120 degrees because the unbonded pair repels more than these do. It is polar because these two pull more unequally than this does, and so the center of this charge will be right here, and then the center of this charge will be right here, making uneven. This is the tetrahedral. It has 4 bonded pairs and 0 unbonded pairs. It has the shape of a tetrahedral because there are 4 and it makes a tetrahedral shape. Its bond angles are 109.5 degrees between each other, and it is nonpolar because all of the charges from the outside atoms meet in the middle and therefore do not have a charge. This is trigonopyramidal because there are 3 bonded pairs and 1 non-bonded pair, and it makes a triangle and has a pyramid shape to it. Like I said, there are 3 bonded pairs and 1 non-bonded pair, and the angles are less than 109.5 degrees from each other. And it is polar because the charge from these 3 are focused about right here, and then the charge from the nucleus is at the nucleus, and they do not cancel out. This is bent because there are 2 bonded pairs and 2 non-bonded pairs, and it forms a bent shape, like that. The bond angles are less than 109.5 because these repel more than what these bonds would, so it would be less than what it would normally would. So it is less than 109.5, and it is polar because the charges from these 2 are focused right here, and the charges from the nucleus is focused right here, and they do not cancel out. This is trigonal bipyramid because there are 5 bonded pairs and then 0 unbonded pairs. It has 3 on one plane and then 2 on its axis, and its bond angles are 90 degrees, which is from the axis to the plane of 3, and then 120 between the 3 on the same plane. And it is nonpolar because all the charges are focused onto the nucleus, and so they cancel out with the positive charge in the nucleus. This is the seesaw because it forms a seesaw-like shape. It has 4 bonded pairs and 1 non-bonded pair. Its bond angles are a mystery, and it is polar because although these pairs cancel out in the nucleus, these two get focused right here and do not cancel out with the nucleus.
This is the T-shaped because the atoms form a T-shaped. There are 3 bonded pairs and 2 unbonded pairs. The bond angles are 90 and 180 between there, and this is also 90. And the polarity is polar because this does not cancel out with another atom in the center. So the charges. This is linear because it forms a line. There are 2 bonded pairs and 3 unbonded pairs. The bond angle is 180, and it is non-polar because the charges cancel out in the center, meaning it all equals 0 in the center of the nucleus. This is the octahedral. It's called that because it makes 8 planes all around. There are 6 bonded pairs and 0 unbonded pairs. The bond angles are 90 degrees between each atom. And it is nonpolar because the charges cancel out in the center. This is the square pyramidal. It's called that because it makes a pyramid with a square bottom. There are 5 bonded pairs and 1 unbonded pair. The bond angles are 90 degrees, and it is polar because this atom does not cancel out with another one in the center, so the charges are unequal, but the rest of them would cancel out. This is square planar. It's called that because there are 4 on the same plane. It has 4 bonded pairs and 2 unbonded pairs. The bond angles are 90 degrees, and it is polar because all of the charges cancel out in the center of the nucleus, as well as these. Ready, go.
The VSEPR theory stands for valence shell electron pair repulsion. This determines the shape of the molecule by the electron pairs repelling each other. They want to get as far away as possible.
Inertia
is a property of matter.
Build.